Hi everyone. Sorry again for the technical difficulty earlier. So I hope now everyone can see everything okay and no echo. So let's jump straight to the news. And so the news of this week. So we have new devices. So we just announced this week the Nexus 4 is a quad-core Snapdragon S4 with a Snapdragon processor, so with a gorgeous 4.7-inch screen, and it has NFC actually, which is what we are going to talk about today. We have also another new devices. It's a 10-inch device, has a super high resolution, 2560. And so I'm sure you guys can read more about these two devices on the internet. And of course, the new version of Android 4.2 is we just announced it. And along with that, we have some also pretty good guidelines of how to build tablet, high-quality tablet applications, and also in general, like high-quality applications. So we add some more documentations, guidelines to help developer to build high-quality applications. Another major news we now have seller support in India. You can read more about that in the blog post, but just want to clarify something. The seller support also include in-app billing, and subscriptions are also included. The Google Plus experiment we announced earlier. So we still need to gather all the submissions, and we will follow up with you guys next week. So stay tuned. So now back to our presentation this week, which is NFC. So let's take a look at what NFC is. Just before we dive into the implementation details, so let's take a high-level overview of what NFC is. So NFC stands for Near Field Communication. It's really based on the RFID technology. It's a short-range technology. So usually when the device or the device to the NFC tag card is between like 4 centimeters or less, communication will start happening. You can also share a small payload, usually in kilobytes, between NFC tags and an Android device, or between like Android devices. So the most common data format people use for NFC is NDEF. So we will talk a little bit more about that in future slides. So what is NFC for? Actually, you can use NFC for a couple of things. The first one is social. I mean, you can share contact information using NFC, which is one of the most common use case. And also you can use NFC to do bootstrapping for Bluetooth and Wi-Fi connections. So Andy will talk a little bit more about that, and also the Android technology, Android Beam. So Andy will cover that in later on. And the third use case of NFC is in commerce. So, for example, like contactless payment, like Google Wallet. But that is a little bit different outside of our topic today. So, because Google Wallet kind of requires the access to the secure element, and if you are interested in become a partner of Google Wallet, you can go to the link below here to send us information. So, but that's not something we're going to cover today, Google Wallet. But so we're going to focus on the technology today. So for NFC, there are a few communication protocols. So so these are the protocols. So I'm not going to spell out all these like ISO standards here, but the key thing here is we have Android classes to implement this, like to talk to these protocols. So so I kind of like highlight that with the bullets here. And besides the protocol, we have different types of NFC tags, and so the standard ones like kind of defined it in the NFC forum. There are 4 major types, and there are products actually implementing these different types. So some of the most more common ones are probably you guys see most are the MyFair ones and the Sony Filica one. So, but there are 4 major types of tags in NFC, and we will see. I have actually kind of a very nice a table to summarize all these, like to put things together. So stay tuned. And besides the NFC forum standards, there are also other types of tag. So the MyFair Classic one is one of them, and so it's also very popular. So NXP is using this type of tag, and it has additional operation you can do with these tag. And we have a special class actually for this, also called MyFair Classics. So what is NDEF? So we talk about formats of data we use in NFC, and I mentioned NDEF is the kind of like the most common standard. So NDEF actually stands for NFC data exchange format. It's really a lightweight binary message format. And one thing about NDEF is an NDEF message can have many NDEF records, and for data with an application-defined payload can be actually encapsulated in one or more NDEF records. So let's take a look at the NDEF record. Talk a little bit more about that in detail. So that an NDEF record composed of a header and a payload. So in the header, it has a 3-bit type name format, and it also has the type itself. It's in variable length. So it's from 0 to 255 bytes. And same thing for the ID. Is kind of optional and not very often used. And then the payload. The payload can actually have data up to 2 to the power of 32 minus 1 byte. So so that's the structure of the NDEF record. So here's the big pictures, like some kind of summary of all the relationship between like all the classes, and so if you look at this kind of the NFC stack, so you have the analog things at the bottom, and then you have the different communication protocol, and there are 2 major types of applications people can build, and so one is using the standard NDEF message format, and within that you have the NFC forum standard type 1 to type 4 tag, and also have the MyFair Classic tag. And the stuff in blue is actually the class, the Android classes we have to the implementation for those particular types of tag. And for non-NDEF format applications, we also have the corresponding classes to allow developer to talk directly through the protocol. So we have all these like NFC 8 class, which is correspond to the ISO 14433A protocol and etc. So it's kind of mapping these raw protocol if the application is not using the NDEF data format. So that's kind of a nice summary of all these things together. So now let's start to talk about like how Android actually read these tags and then how to dispatch these tags to your applications. So again, the two major like category. So one is the tag with using the NDEF format, and other one is using the other non-NDEF format. So so we have different action type. So it's actually following the order. So we first try to see whether something matched the NDEF data format first. So we have an action called NDEF discover. So if there is an activity that match that action, so we will route the intent to that application. So we will see some example of how to set up these like intent filter in your application later. And then so back to the picture, if the NDEF discover action is not we don't see any like NDEF format tag, we will fall back to the tag discover actions, and then to the tag discover actions. So this is kind of how the Android system decision tree to decide how to dispatch all the data, all the NFC tag it reads from the phone. So now, how to request NFC access in your application? So as you guys can probably can imagine, so there's definitely has something to do with the manifest. So first things you need to do is to add a special permission as a android.permission.nfc. And for filtering your application in Google Play, you want to use the feature tag, specifying the hardware, NFC hardware. So if NFC is really an optional feature in your application, you can consider setting the required attribute to false, and you can also check NFC runtime availability by using the get default adapter method. If it's equal null, that means NFC is not available in that particular device. So another thing is you have to set the minimum SDK version in your application. So the minimum SDK version that will have NFC support is API level 9. So in this level, we will support the action tag discover action, and but we kind of recommend developers to at least specify level 10, because it has a much more comprehensive read-write support in level 10, and also we can do foreground and foreground NDEF pushing. In API level 14, we add Android Beam support and also some other extra methods, convenience method to create NDEF records. So I guess at least use API level 10. That's our recommendation. So filtering. So let's take a look at how you set up your activity to capture these NFC intents. So you can so one of the actions you can filter by is the NDEF discover action. You can, in this example here, you can filter by meme type. So you can specify like if the meme type is text plain text. That's how you have a data tag and specify the meme type. That's how you filter NFC message by meme type. And if you want to do filtering by URI, you can also do that. So it's a different. It has a different data tag specifying the host or prefix of your URL, and the next actions, like kind of after the dispatch system couldn't find a match on the NDEF discover action, we will fall back to this tag discover action. And in order for this to work, your application have to specify an XML resource file to specify the list of technology, the NFC tag you're reading, your application. The list of NFC technology has to support in before your application can process the NFC tag information. So so in this case here, so what you are trying to say here is your application will only take NFC tag that can support the entire list of NFC technology. So it's a pretty long list of things, and I think in reality you probably only want to specify a field, because this is really end cases. So you're trying to find something that support all of these technology. It's not all. So how to do all in the tag list? So if you specify multiple resources, like this example here, so you're trying to filter something like if the NFC tag is supporting NFC A and NDEF, and all is support NFC B or NDEF, if both of them will match, and your applications can serve both of these NFC cards. So if you have all need to use the all semantics, this is the way how you define the tag list. So so another fallback is using the tag discover in your activity, you pretty much just filter by the tag discover tag actions, and then you add a metadata tag specifying pointing to the resource XML file. So this is how you include the filter in your manifest. So did I miss? Okay. Yep. So how to obtain information from the intent? So it's pretty straightforward. There are two ways you can do it. If you want to have the raw NFC tag, you can always do the get parsable parcelable data extra using calling the extra tag, and it will return you a tag, and you can just look through and get it to find out the list of technology. But there's also a very convenient way if you know like you are only like processing NFC tag with using the NDEF data format. You can use the NDEF messages extra to get a list of NDEF message. So the code snippet here is really an example of how you get the NDEF messages. So you pretty much you get a list of possible, and then and then you create and then you cast these like raw messages to the NDEF message. Just loop through it. So the next session, Anirudh is going to talk about Android Beam. So I'll pass it to Anirudh.
All right, thanks, Tony. So to begin with, what's Android Beam? It's something that based on something called NFC NDEF message push. So this is about pushing messages from an app that's running on the foreground, an activity that's running on the foreground, to another activity running on another phone. So that's the push part aspect of.
By the way, can you guys see the slide when Anirudh talks?
I can, Tony.
Andrew, you can? How about Andrew? Andrew, can you see the slide when Anirudh talks? Andrew, can you see the slide?
He has a chat message, but he can highlight it to see. So it's probably not getting recorded. Let me do something. I will share my my desktop instead.
Okay.
So, all right, I think we've got my slides on the screen now. So, right, as I was mentioning, NFC is based on NDEF message push format, and it's basically NDEF message, like Tony explained, is something that contains 0 or more NDEF records. The first record being something that describes the URL or the contains the URL or the MIME type of the content that your NDEF message contains. For example, if it's an image, you would have something with the image MIME type, or if you have text, you would say ASCII as the MIME type. So that's your 0th position NDEF record in the NDEF message. Now, this message with these records is pushed from one device when in close proximity, and that's the basic concept of NFC. When you bring devices in close proximity and your app is running in foreground, that's when NFC Beam is activated, and it tries to push the message from one device onto the another one. So as a programmer, how do you enable your app or make your app Android Beam capable? It's quite simple. There are two options of how you can do that. The first one is you basically invoke the method set NDEF message push. So when your app is running, your activity is in foreground, you call this method, and this method is usually used if you have sort of a static data to be pushed. For example, you may want to push the link of your app to download, and this is something static, and this is the method you would use when you have to push that kind of data. The other option is that you can have your activity implement something called create NDEF message callback. And so as soon as your activity then comes into foreground, the system invokes this method on your calls your activity back using this interface, and the only method that you have to implement from this interface is the create NDEF message method. So this method is where you have to provide the implementation of how you create the message and return a message from the method. So the framework would invoke the callback, and this method is called, and at this point you should return the created message, NDEF message. So this is more useful when you want to add some context to your NDEF message. So depending on what state your activity is, or maybe if you, for example, if you're on YouTube and you have some URL that you're watching right now, which you want to push to the other guy, so there is some context here, and so you would use this implementation of using a callback and create the NDEF message appropriately by using the context from your activity and embedding that data onto the message and parceling that message through. So, and when this is done, what you get is a callback called set NDEF push message complete callback. This is the callback that's invoked when the system is able to reliably beam the message to the other device. And so what we've discussed here, if there's a short snippet of code on how it's implemented. um, Very simple code. On create, we set the endf message push callback, uh, and this is the other implementation, which is the implementation of implementing an interface callback. So we have a method implemented here called create endf message, which comes from the create endf message callback. Uh, at this point, what we do is we construct a endf message. So like we said, endf message is basically an array of one or zero or more endf records. So in this case, what we do is we have this method called create mime record, and this is a custom method. So what create mime record does is basically creates the first endf record as the mime type of the data. In this case, it's ASCII is the mime type because we are sending some text across. So what it does is puts the mime type as the first endf record, and then uses the rest of the message. In this case, it's just a text that says "beam me up," and it uses this to add to the payload of the endf message, which is the records following from index 1, 2, 3, and as long as your data is. So, but the first record is always the mime type. And how do you receive this beam message? So what we've done till now is we've created the endf message, and when our activity is in foreground, the system will try to beam this message. So on the other device, which is in close proximity, you have the NFC. You have to filter your NFC intent action endf discover. This will make sure that the system knows that you have a component, or you have an activity that's interested in this intent. And when you declare this intent, you declare it with the URL or MIME type of interest to you, which means, so if, for example, our code that we just saw in the last slide was trying to send you some ASCII text. So you may declare in this, when you declare this in your manifest, you may say that I'm only interested in text. If there is an NFC intent with a message that carrying text, I'm interested. Or if there is an NFC message with carrying some image data, I'm interested. So you declare also your MIME type of interest. So again, like we said, it should be the same as the first endf record of the incoming message, because that's where we kept the MIME type of the message. So once you do that, and let's look at some simple code. Here it is. This is the method that's invoked on new intent, which is what will get called when you are filtered for that event. So this method is what we are invoking on new intent, and so that means there is an incoming message now that we are ready to process. So what we do now is using the get extras of the intent, we try to obtain the raw message, which is the endf message. And the endf message is the 0th or the beginning element of the raw message array, and this is the only element right now. So once we get the endf message, what we want to do is the actual message, because the 0th element is the MIME type or the URL type, what we want to do is get the payload starting from the 0th message. So we say message.endf message.get records, and we use the method get payload, which will give us the following records from the MIME type, following the MIME type record. And this is basically the text message that we had, which said beam me up, and this is how you obtain the message. So as you can see, it's just 10 lines of code on both sides, on both devices, and sending the intent as well as receiving the intent, and your app is now NFC beam capable. You may have some more use cases, like Tony discussed, how to set up a handshake for Bluetooth with NFC, and then in this case you might want to exchange some more data of different MIME type between the two devices, if you want to initiate a Bluetooth connection, or if you want to send across images or some other sort of text data. But in general, this is how NFC works, is put the MIME type onto the first record, create the other records with the payload, and push the payload across, declare the intent NFC discovered, and then once you have the intent in your activity, on new intent, you try to process this message by obtaining the raw record and then getting the payload from the record. And all this happens on foreground, and that's how NFC Beam works. Your app has to be on foreground. So just a use case here that what may happen sometimes is that there may be multiple applications on the device that may be interested in listening to NFC messages, incoming messages of a certain MIME type. This could be very common for something like a contact or image or text. There may be multiple applications. So if your application is sending that message or is beaming that message, and you sort of want to guarantee the delivery of the message back to your app on the other phone, what you can do is use something called application record, and this is Android application record, AAR. This is very simple implementation. What it does is just puts the package name of your app in the endf message. So which basically means inside the endf message, everything is an endf record. So this basically means that we are creating an endf record which contains the package name of our app. So this is to specifically target your app at the receiving end of the message. This increases the probability that your app will be the first app to pick up the message, or your app is the intended receiver of the message. So just to summarize what we saw in terms of a graphical illustration, on the top, you see a device that has the beam foreground UI activated, which means the device is ready to beam a message. At this point, we use the create endf message method from the create endf message callback interface to create our message and send it to the system adapter, the NFC adapter. So once you create the message, this message is beamed to the other device using NFC technology, and if you have the intent action endf discovered on your app, this message will be delivered to your app, and the format of the endf message will indicate what is the MIME type or the nature of the data in your message, and based on this you will have your intent filter saying declaring those MIME types, and once you receive the data, you're able to parse it using getting the raw record and then looking through the record for the payload. So this pretty much summarizes what we have to offer for Android Beam right now. Yeah, that wraps up our live presentation for today. So Tony, we can move to Q&A.
Yes, sure. So let's take a look at the questions we have on. Okay. Let's take a look at the questions we have on moderator. So the first one I see is from Anatoly from Ukraine. So I need to authorize users, but I don't want them to fill some data manually. So after receiving a confirmation email, I want exactly my app to be started. I can use the app URI like this, my app : / some data in Gmail client, because it ignores the URI. So So we talked about intent filter. So I believe in the Gmail client, actually standard HTTP URI is actually is working, and so you in your application. So one suggestions I can think of is you can have an intent filter actually filter by some specific URL. So if you have some URL, your application can understand. So you can and you can use that to filter by that. So you don't need to use a different kind of scheme. So that would be my suggestions. Anyway, do you have anything to add on top of that?
Yeah, I think that's the easiest way to go through, is something that the framework already understands and the Gmail app understands, is the HTTP URI. The other thing I could think of is maybe your confirmation could come as a file which is of your application type, and once the user downloads the file, maybe a patch, like an unlock patch or something. When the user downloads that file, your app is registered to open the file of that type. That may be another way of handling this thing.
Cool. So The second questions we have here is anything new about NFC in 4.2 API level 17 that you are not allowed to that you are allowed to talk about. So I haven't seen actually anything I am aware of like super new on 4.2. So I need to double check that, and if we have something that we can talk about, maybe we can talk about that in the next or future ADL plus. So yeah.
Yeah.
So anyway, why don't you take the next question?
I would like, so the question is from Fight Engineer Austin, Texas, and the question is, I would like to replace the incoming call screen with a small overlay, but it appears that there is no way to disable the default incoming call screen in via an app. Any creative ways of achieving the desired result? Acquiring root is a possibility. So I would not comment on what you can achieve by routing because I'm not really familiar, and not something we recommend anyway to our users. So there is, yes, you are right, the phone application is the standard application, and you can't put textual or graphical canvas overlays over top of it. Uh, yeah,
Yeah,
that's
it's
pretty much
really for
how.
security
Yeah,
reason. Yeah.
yeah, pretty much.
Yeah. The fourth question is coming from Russia, um, from Anobachev. So I have a positive experience on Android platform for porting application built on frameworks like Spring, Hibernate, AOP, etc. I would like to happy to continue development of cooperation in this field with you. So doesn't really seem like questions, but we are glad actually you have good you have good luck experience with porting your applications. Feel free to leave us some more comments or some specific questions in G Plus in the future, if you have anything. So
Uh, yeah, just add something to it. I think
mhm.
there are some projects, open source projects, that are catering to these frameworks or adaptations of these frameworks on Android. I surely know there is something called Spring Android, and definitely Jetty, right? So there is a web server, tiny HTTP web server or something like that available for Android, and these are open source. So I think a good avenue for you would be to work with these guys. Spring Android is a project where you can go and contribute, and yeah, so this is how you can work with community. That's one idea of doing it.
Anyway, want to take the next one?
Yes. So the next question is from Shiv Shankar, Hyderabad, India. The question is, I need to process. I need the process of changing the bitrate of an audio file, which should be used on Android SDK. So the question is not really clear to me. So I get the first part, that process of changing the bitrate of an audio file. So we have media codecs where you can have an input buffer and an output buffer, and you can specify the types or the media properties there. And but I don't get the part where you say which should be used on Android SDK. So I mean, do you mean like what should work on the Android OS, or? So yeah, I'm not really clear. Maybe if you can drop us a comment on what do you want to say with the second part of your question, we'll be able to answer. But just in case, for handling audio and video pipelines, you can use Media Codec, which is available on the Android SDK.
Okay. So the next question is from Sweden, from Ken. So random users of my app, maybe one user a day out of 200,000, get a Java IO file not found exception, permission denied when calling context open file input. A few seconds later, the file reading works. So Mac and I actually took a look at the links you have, and doesn't actually give us too much information. Maybe we really need to look at some code before we can fully answer this. But one idea I can think of, maybe is it possible to have some sort of racing conditions like that the files actually really doesn't exist if, in certain cases? So that's my kind of guess. How about you, Anirudh? Anything you can think of?
Not really. I saw the stack trace there. Maybe if you can obtain a buck trace from the device, which will capture more information on what's happening. I can see there is a permission denied by the Unix APIs there. But yeah, I mean, a buck trace would probably help narrowing down what's happening. So if you can grab one from your users.
Okay. So,
Right. Maybe even random failure of flash drive or storage.
right. So, how about the last question, anyway? You want to take that?
So, right. So the question is, what are the various best approaches to develop static pages? Each page contains text
I
and
think you skipped one.
all right. So that's the second last.
Yeah.
Is card emulation supported? If yes, then how do we do card emulation on Android devices? Google Wallet is able to do. Why not other? Uh, right. I don't know the answer to this one. So Google Wallet. I don't know. Tony, do you have any insights on how the NFC is working?
I I believe actually emulation is supported because I heard developer has done that before, and also like um, when one Android device uh, talking to another Android device is really some sort of like emulation. So, but I'm not 100% sure is it really the true emulation. But so I don't have a direct answer. So maybe we can take a look at that and get back to you next week. Follow up with you.
Also, I believe Google Wallet is probably not using a stable set of interfaces right now to work against NFC, in the sense which can be published as part of SDK and available to everyone. So it's sort of experimental in what it's doing. And once we have some kind of stable interface, that may become a public SDK facing API.
Sorry, the question was posted by me, so I'd like to have a question on this. The APIs that we are talking about, I'm referring to Seek interface, which has been provided already and has been implemented in many of the devices, such as the Samsung and Sony devices. The Seek interface. What we find is that it is not yet been implemented in the OS. That's why it's not standardized. So,
Right.
just hoping to get some kind of info if it is going to be standardized in future anywhere. Is it there in the roadmap or not? Something like that, because people want to do something with the Seek interface. They want to access the SIM card for certain reasons, because the secure element is the first thing. They want to access secure element, and being not able to do is kind of a limitation for many of the applications. So looking forward for how is there any plan like that you guys are having somewhere?
Yeah, I mean, definitely there's work in progress. Even Wallet when it was launched, and even now it was bundled with specific devices because, like you said, it's not a stable interface right now. There are different implementations across vendors, and so this is something that is being worked at. And I don't know the timelines on when we'll have something stable to be exposed as a backward compatible API for all time, but there is work in progress, and I can try to find out more from the teams and update you on what progress is Wallet seeing.
Also, a small question. Google Nexus S used to have compatibility with the SWP chip, so it was able to have a communication over there. Google Nexus was Nexus series, the previous one, the Nexus 3, which you can call, there is the Nexus wasn't having it. Are we expecting this to be there in Nexus 4?
Sorry, can you repeat the first part? I didn't really catch with the audio breaking.
I'm saying Galaxy Nexus was not having it, yet Nexus S, the previous one, was having the Seek interface. It was having the SWP chip, so by which the SIM can communicate on the NFC level.
Mm-hmm.
is there any possibility that Nexus 4 will be having it? Is there any chance? Do you have any idea about that?
I can find out. I can find out. I don't know the answer upfront.
Thank you. Thank you.
All right, so maybe you can join us next week or for the answers, or we'll try to post it to G Plus on the same thread.
Yeah, try to post the question in G Plus to us, like just so that we have a record and we can follow up easier. So thanks.
Yeah, my ID is Android Devani, and that's Tony Chan. So you can find us on G Plus, and maybe you can just tag us to post a question, and we'll look forward.
I'll do that.
So let's take a look at the last question. So what are various best approaches to develop static pages? Each page contain text and optional images. I'm thinking to use one activity wheel pager. User should feel like pages of a real book, while the user flip left and right through pages of data. So,
right. So I mean, depending on the size of the book that you're talking about, 200 pages, maybe you don't want 200 fragments sitting in a view pager with data flipping across. So what you probably want to do is, instantiate something with 5 fragments and try to buffer or cycle through your content of the book. So keeping some pages in the buffer so your user can go up and back, and then maybe use just animations on a given fragment or a view to have the content of one page of content of the fragment being replaced, the text and the image being replaced from your data source again. Yeah, I mean, the strategy of using an activity with a fragment and some animations would be good. So Google Books itself was written with RenderScript. RenderScript is a low-level graphics and mathematical computation library that we introduced. So I'm not sure what's the kind of development you'll see on it going ahead, but that's what Google Books was using at that point of time. But again, you have the options using Java, OpenGL 3D interfaces, and to give those effects and animations, and even the framework object animated properties can give you sort of animation to give the effect there. But yeah, I mean, I would look at a fragment with a view containing text and images and some animations there.
Cool. Well, I guess that's all we have in terms of questions, and so thank you very much for watching, and I hope you learned something about NFC today, and so we will be back next week. Hopefully, Anchor will be back too. So. Anyway, anything else you want to add before we?
Just a reminder that we are running the Android experiments, and the first one was about connectivity API. So if you have some last-minute submissions, please go on. And if you want to showcase your code or have us review it or showcase what you've done, please submit it to the Android experiments page. We are looking forward to it.
Cool. All right, I think that's it. Thank you very much for watching, and we'll see you next week. All right, bye.